Hi, my name is Troy Bowman. This is a project I worked on with Thomas Batchelder under Dr. Livingston, and this is a automated CNC loading using an ABB robot. So here is the Haas controller. It's going to be running a loop script where it's going to set the table into the initial position for robot loading. It's going to be cycling through different macros that are being sent from the robot controller. So it's going to be running, and this will now tell the robot that the telnet communication protocol is running so that the actual machine can work. So I'm going to go ahead and initialize the robot, and then I'll start loading autonomously. So first thing, I'm switching it into auto. Then I'm acknowledging the change from manual to auto. I'm going to send the program pointer to main. So it's going to be at the start of the program. And then I'm going to start the application, and this is for starting the camera. It's starting the robot. You can hear the motors turning on and off. Grippers are empty. And now details from the in-feed conveyor are going to start moving forward and waiting for the robot to see. So now if you look at that web screen right there, it's going to detect the feature, and it's going to dynamically move the robot to it. So here it's starting up, it's switched to a different tool. It is now running the subroutine, and we can go and turn the feed all the way up. Now this is for demonstration purposes, so it's not necessarily cutting apart right now because I still want to be able to use these bugs, but in the future, different robot grippers and a little adjustment of communication and programming, parts can actually be fully made in this machine. So if you can see right here, the robot is now waiting for an OK to load signal from the CNC, so it is ready to load the next detail whenever it's ready. You can actually see the robot waiting right there. So we wrote kind of a longer program to make sure that the robot is actually listening for the signal, so we can make sure that all the safety protocols are actually working. It's going to do one more tool change. And so it's going to do this. It's going to change back to the first tool. You're going to want to be right here so you can see it load and unload. Now it's going to put that down on the lower conveyor belt. And I'll set it back up. So after the robot exits the CNC machine, it sends a start signal, and then the next part is going to be made. And as long as there's parts on the conveyor and parts being seen by the camera, it will continue to load and unload material. So some things that we would probably do differently next time if we had more time was, as you can see, the side door for the Haas, it's going to be open. So another procedure needs to be written for the robot to actually open and close that door automatically. So this can be done using our 3D printers on the other side of the lab, printing something for the top of the robot so it can actually lift it up and lock it as well as unlock it so that parts can actually be cut with coolant. Because if parts are getting cut and coolant's being used, you're going to need that door shut, unless you want a really dirty work environment. The other thing is making different end effectors for the robot that can grip different geometries of parts, because right now we can only grip spherical objects or round objects, but it would be great if we could also grip the same gripping system, square or box-like stock material, because those are the most common types of material you're going to see loaded in CNCs. That, and also just making a full part or one end effector that has custom adapters for the outline of whatever you're actually making pulling off the machine. So having the full process, not just all the communication protocols within, everything else works, but that's what we would probably improve upon.
All right. Thanks a lot.